I love that. That's good. Nested layers of subtext. We keep going. All right. So the next speaker is Matteo Borri. He is from Italy originally. He's been here for many years, and he was really helpful for me when I had sort of this singularity phase when I was working for Ray Kurzweil and doing some interesting stuff with Ben Gortzel in AI, and I was the person that wrote everything up because I thought it was so cool, and then I could learn from these people while I was hanging out with them, and he would help me understand stuff I couldn't understand, and he was building these little ant bots, which were these little autonomous robots that could go along by themselves and were built really inexpensively with equipment you could buy at Radio Shack. And it came in a kit, so a kid could learn about robotics building an ant bot. And then it's totally been like ripped off and used by lots of different things now. But he was doing this in 2007? 2008?
Well, the first ant bot was 2007. Then when Android happened, I was actually the first person to put together a commercial Android robotic system, which was kind of funny because it pissed off some people at Google, and there were a few drops of blood spilled on that one, even, but that's another story.
Okay, so you start to see why I've been trying to get here to come to talk for a while, because it's always sort of fun to just talk about the latest thing that he's doing, and then he can answer a lot of questions about stuff. He also helped me with a virtual museum that I'm building, which has a Timothy Leary wing, an Aaron Swartz wing, and a Chelsea Manning wing. He's been helping me flesh that out. And he helped me get the meditative blowout tool together, and so he's just generally very, very useful in a lot of ways. But today, he's going to talk about doing interesting things with 3D printer, and he was on a simulation. It was a Mars simulation in Utah, right? Mars simulation in Utah. Mars Society, that's it, sorry. And that's when they put a bunch of people in a simulation and see what they need. Do they have enough? Did they give the people enough time? And what they found out actually was that they go crazy more than anything else in the tin can, more than anything that they need. But one of the things they developed during this time was a scalpel with the 3D printer. And so he's brought some things too that he'll be passing around that he made, and we're ready to go, everybody. Matteo Borri.
Well, Lisa already said pretty much everything I had to say, so it's all right. Okay. She sounds a lot better, and she doesn't have an accent, so you're probably better off. Anyway, so who am I? I'm a fat idiot who builds stuff. Sometimes he gets shot into space, not as often as I would like. And the reason why I was originally here was to say something about the future of 3D printing, but the thing is that I have no idea. And it's a good thing that I have no idea, because what's interesting about 3D printing is that if you look at it, 2009, 8 years ago, right? Not the Middle Ages exactly there. You could buy a kit, you could try to build a wrap, you could succeed or you could fail. I failed. I bought a wrap kit and I made a complete pig zero of it. A couple of years later, you entered the Apple II / Altair era. You could buy kits, they got together, you had to fiddle with it for a week, and then you could build stuff. And then just a couple of years later, you had MakerBot, you had SolidOodle, you were already in the PC / Amiga era, if you want. And that followed up with, MakerBot doing what they did. I'm sure you were aware of it. They basically just say, we're open source, we're building off wrap, we're building off ramps. And then they decided to close everything and add a bunch of proprietary stuff. And now we're at the point where we're finally at the 3D printing equivalent of, it's 1996, internet is becoming common. And that's where we are with 3D printers, because on one hand, you can get your 3D printing web TV, you can get a DaVinci, which is super cheap, but you have to buy their cartridges, and so there are people that are hacking the cartridges, obviously. You can buy a micro 3D, and you can get a 3D print. You can get a good 3D printer that you don't have to fiddle with for a week to work for $200. Now that's good news. The bad news is that who has $200 to spare? Who's got a 3D printer here? Not that many people. Again, it's like, it's like 20 years ago, people were starting to have the internet, but usually you were like the only guy in your blog that had it, and, people came over and you would maybe download some porn and sell it to them on floppies. Hey, I did that in high school, okay? Anyway, point being that the whole 3D printer stuff evolved super fast. This whole thing, we had the equivalent, we had all the little dramas, we had all the big dramas, we had the commoditization of 3D printing in less than 10 years. This is new. This is not something that has happened before. This is the pace of innovation accelerating. We keep hearing about it. Finally, we saw some of it. That's a good thing. Now, where is it going to go? Again, I have no clue. I don't think you have any clue either. I actually don't terribly care. So this was done in, this is something that showed up at the Mars Society convention about 2 months ago. 4D printing, I have no idea what the heck that even is. It's just that this is the next wave. People are just starting to do stuff like Fontus. People are starting to do a bit of snake oil even. People are starting to make wild gases. It's fine to play with it, but it doesn't get us anywhere. Now, this particular printer in the picture there is a 3D printer that was outfitted with a laser cutter. Now, this is a solid-state laser cutter. It's called the Cheapo. We kickstarted it in 2014. They got better since. It used to be 2.5 watts. Now they're 8 watts. That's actually enough to cut stuff, not just engrave. Design is open source. I give you the design, I give you the schematics, I give you where to buy the parts right here. First link is everything that I'm pointing out here is on my wiki. That's the address. Look it up there. It should be there for download. If it's not, there's an email link. Send me an email and tell me that my wiki's borked again, and I'll fix it. That's easy. Point being, you can get a 3D printer for $200. You can get a laser cutter to go with it for $100. I sell these for $200. The parts cost about $100. I designed the PCB and the metalwork specifically so that they can be built with hand tools. You have to be precise. You have to print a jig. You have to be careful with it. But that's the only precision bit of metalwork you have to do. Everything else you can get at Ace Hardware. Everything else you can get at Home Depot. It used to be a point of pride for some of us to design stuff that you could go and buy the parts for a Radio Shack. Now there ain't a Radio Shack anymore, but it's not a bad design philosophy still, because that's actually something that the Mars Society guys wanted me to say at the time. You're going to Mars, you're going to Antarctica, you're going to Puerto Rico right now. You have to design your stuff in a way that it's easy to fix, and people who kind of sort of don't know what they're doing can't fix it. Now look at this guy. Plus red, minus black, PWM optional white. 1 customer in 10 manages to connect the red wire to the negative and the black to the positive. I'm serious. I had to add a diode to the design just to deal with that. Point being, if you make these things, make them repairable. Yeah, no, there's nothing to show there right now. I don't care. What else? Oh yeah, this is another thing I've done. This is the one thing you're not gonna find on my wiki. This is a cell phone-based spectrometer that I built for Dr. McKay at the Ames Research Center, and the evolution of that is hopefully gonna go on the next Mars rover if I can get my immigration papers done right. If not, I'm just gonna open source it at some point, I suppose. But it's got nothing to do with anything. What I wanted to say, if anybody cares, is, again, 3D printers exist, they're cheap, they're commodified at this point. You can just get one made in China, and we're at the point that the made in China stuff is decent. Laser cutters, same deal. Now this is an 8-watt laser cutter. You used to have to spend a couple of $1,000s on this thing. It used to be big. It used to need water cooling. In less than 10 years, they got this size, and they actually do cut stuff. This here is a little gripper for one of my rovers. You see, it's got 3D printed parts, and it's got laser cut parts. The machinery that you need to produce this in your house costs less than $500, which would be great, except it turns out that roughly half of the people living in this country don't have $500 to spare, even if they have an emergency. How do we fix that? You could say it's not my problem. It's certainly not, I mean, it's not my problem. I'm not American. We have similar problem though, so it is my problem again. So what you do is, if you have a 3D printer, maybe consider sharing that information with a neighbor. How many of you know your neighbors? About half. That's actually pretty good. A lot of people don't. See, I moved here in 2010. I introduced myself to the neighbors. You know, it's a bunch of little townhouses. You just, you know, knock on doors and stuff. And about the 4th or 5th person was this old lady who thought that I was a sex offender because I was introducing myself to the neighbors. And that was a bit of really surreal conversation because I didn't know that there was a thing in this country. And it was this, you know, it was this older lady, 75 years old maybe. And she keeps asking me if I'm some kind of sex offender. And I'm like, are you hitting on me? This is a bit surreal, you know? Anyway, point being, having a 3D printer right now is like having a personal computer in 1994. It's a thing. It's not a common thing. Most people don't know what to do with it. Most people would benefit from having access to one, but they don't know it yet. So, you know, you get a 3D printer, you can print cute little gadgets, or you can do something useful with it. Now, I actually lost the damn thing. It's in here somewhere. One of the first, you mind if I just ditch the microphone? Formula, it's on my wiki, which I'm gonna show one more time. Up there. Again, if stuff is missing, everything I'm saying now, call me on my bullshit, please. If anything is missing, email me and then say, hey, this page is missing. Hey, your recipe for your filament is supposed to be there. It's not there. I'll fix it in, you know, half an hour when I wake up. Meantime, this filament here has been designed to go on regular printers. If you go like a 1.75 millimeter extruder will take it. If we printed a 1 centimeter cube, it broke at about 1.5 tons.
You have to speak into the microphone.
Sorry.
The webcast can't hear you.
Sorry. We printed like a 1 centimeter you know, cube for this. It broke at about 1.5 tons, which I'm told is decent. Recipe is very simple. It's ABS, a little bit of graphene, not a lot because that's expensive, and a little bit of atomized aluminum, 3 microns. I forget the actual percentages, but again, that's what we got a website for when it shows. There you go. And that's really all I got. I mean it. If you have any questions about what I've been building, like she was saying, ask away. Otherwise, boo me off the stage, but pick up a bit of filament before you go. Out. Anybody want some of this stuff? Come get it. It's ABS. Okay, this is ABS, a bit of graphene, and a bit of aluminum. Now, it's not. Yeah. No, they're all the same crap. Basically, okay, so this was done saying, okay, I want to, it's brittle, but it's strong in compression. Try it. Same stuff you do with this, except it's going to be stronger. Mostly I was messing around. What I wanted to do the ribbing for a glider, for a glider's wing. And I'm like, I don't want to buy aluminum. I want to see how much of this I can 3D print without going out and buying stuff, because I didn't want to go out and talk to people at the time.
I just introduced myself this last week. I'm from Dallas, actually.
Nice.
He sold his company for $30 million. Heading out to retire, and he's got a couple $4,000 3D printers.
Right.
And he's big on it with the intersection of like technology with Adreno. And no, I haven't.
See, Parallax Propeller is this really cool thing. It's made by Parallax, which is a company out here in Brooklyn, California. Sure. It's an 8-core microcontroller. Yeah. And the cute part is that they were doing it when the multi-core was new.
Seriously, talk in the microphone.
I want people to hear the good-looking guy. Come on.
Please.
And no, it's again the Arduino is nice because it is open source. By the way, that's not entirely true because the hardware is not open source. The Parallax Propeller, you can actually download the Verilog files if you want to emulate it on FPGA, and they will give you the photolithography files if you ask.
Awesome. So other than that, are you seeing any other emerging trends? I know you showed the picture with the 4D printer. Were you making that point just to show that it was a gimmick, or is that kind of where the future is?
Well, I'm trying to make the point that people don't really know where it's going to go. Now, 4D printer can be a thing. It's not really a meaning. It's more like a buzzword that, you know, that was Dr. Jewell for the Mars Society. You can, once you have a 3D printer, on top of that 3D, you have a head that moves around and, you know, barfs out this stuff or ABS or whatever.
Right.
Great. What else do you have? You put this guy on top of the extruder, it's also a laser cutter. You can put a pencil on it, you can replicate handwriting, you can use it to auto-sign things if you feel like, you know, fucking with lawyers a bit. You can, if you make it a bit stronger, you can put a Dremel on it and you can cut balsa wood. No, I just used the roll of PLA.
Oh, okay.
That's got nothing to do with it.
So are you from San Antonio, or are you living here in the Bay?
No, I'm from Italy. I went to school in San Antonio, and I moved here because the NASA guys wanted to talk to me.
Oh, come on. So how crazy did the Mars simulator drive you?
Well, the Mars, well, I'm here.
Yeah.
I'm here. I look
Good.
at.
And I said you heard about that too. Well, you're kind of shocked.
So the Mars Society stuff. That's actually something. So that's actually something. The original idea for this talk was design stuff for Mars. You know, that's cool and all, but let's look at designing stuff for Puerto Rico instead. It's a similar idea. You're there, you're not getting help, you know, whoever's gonna give you help is weeks away maybe. In the case of Mars, it's physics, and in the case of Puerto Rico, it's bureaucracy. And you're gonna have to improvise. So what you do is that you design things so that they are easy to improvise with, they're easy to MacGyver on. They're easy to riff on. So for example, this guy here, I'm just gonna break it for now. I can't. I need to grow some nails. This guy here's got a prototyping area. If people want to add like a safety switch, they can. A new one already has it in, but if people want to add other stuff to it, they can. Point being, if you're designing for an environment that you're not familiar with, and this could also apply to software. If you're designing for something that you want people who don't know what they're doing to mess with, to adapt to their uses, sometimes it pays to not go with the most efficient solution. Sometimes it pays to go with something that you know that somebody who doesn't know what they're doing is going to look at and say, oh, okay, maybe if I move this thing, I will not bork it completely. That's good because, one, now they get what they want, and two, they are encouraged to experiment more. Anyone else, or can I go home?